Hey guys, welcome back to my workshop. You're probably wondering what I'm doing. Well, what I've got here is my Airco Healy welder. This is actually it's badged Airco, but back in the day it was made by Miller. This is the same welder as if you guys follow Adam Booth on his channel. This is basically the same welder he has, only it's badged Airco. Anyways, this welder, it's a transformer welder that weighs in at somewhere around 850 pounds. So it's very heavy. I wanted to be able to roll it around in the shop. So years ago, I put 4 casters under this thing. Now the casters that I put under there were pretty much what I had on hand. And then, luckily for me, I ended up noticing one day that the welder looked like it was tilting a little bit. So upon closer examination, I realized that the caster in the lower front corner had started to buckle. So I quickly grabbed one of my machinist screw jacks, one of my larger ones, and was able to get this underneath that corner and crank it in there, basically stabilizing the welder so I didn't have to worry about it falling over. I have this nice Armstrong screw jack. I would have liked to have gotten this in there, but there wasn't enough clearance. And the problem is, again, this welder weighs 850 some odd pounds, so the only way I can really lift it down here in the shop is to use my Harbor Freight Pittsburgh Tool shop crane. This is what I used to put together the Wells Index mill once I got the components down here in the basement. The Vernon lathe. Basically, it's going to be what I'm going to use to put the Hendy lathe back together someday, hopefully. Been very, very handy. When I'm not using it, I put it way up out of the way. Then the problem is the shop gets into a mess. There's stuff everywhere. It was a project just to clear a path, just to get this darn crane back over here. But I got it over here now, and I lifted it up. And I'm looking underneath here, and I'm thinking I'm going to put new casters on this. I picked up a heck of a deal at a yard sale on these casters right here. They're nice heavy duty casters, ball bearing. They've got locks on them. I actually got like 2 boxes full of these. They're brand new, and the story goes, the guy had a garage on his property and he did car repairs, and he bought some of those big rolling toolboxes. I don't know if they were US General or if they were genuine Matco or Snap-on or whatever, but for whatever reason he didn't want them up off the ground and being able to be rolled around. He wanted them just sitting on the floor. So he never installed the casters that came with it, and he had bought several of these boxes. So I stopped at his yard sale and he had 2 boxes laying on the ground, and he had a price on there of $1 a piece on these casters. And I was like, at $1 a piece, that's already a hell of a deal. But he hadn't had any takers on it, and I wasn't the first one at the yard sale. I was surprised these were still sitting there, quite frankly. I mean, I don't want to like beat it to death, but these are actually pretty darn decent casters. So I said to him, I said, well, you got $1 a piece on them. You do a little better if I take them all? And he said, well, how many are in there? And I counted them up, and I forgot what we ended up dealing. But I ended up getting these for less than $1 a piece by taking them all. So I've got several of them that are like this, that swivel, and then I've got some of them that are fixed. So they only roll in one straight line. So my thinking is I'm going to put 2 of the straight ones on the back and 2 of the swivels in the front, and that should give me plenty of versatility for moving it around. So here's a close-up look at the casters that I put on here, and they're only stamped steel, these frames, so that's the weak point on these. Some kind of composite resin that the hub's made out of, but that's actually holding up just fine. And actually most of these casters held up fine. It was just that one in the front that started to bend, and in actuality I'm not even convinced that the frame on the casters bent. It might actually end up being the frame that it's bolted into, because what I discovered on the back side is, unfortunately, I've got a area that rusted out in the back where I didn't see it, and that whole back corner is collapsing. So that caster right there might not even be really that bent or bent at all, It's the frame that's failing. You know, wherever the garage that I got this thing out of was unheated, and this was a lower level, and I think they may have even had some, you know, water problems in there or whatever. And so when I got it, I knew it had this rust, surface rust on it, but it still seemed like it was pretty solid at the time. But apparently underneath a lot of this flaking, there's real structural issues. So I am not going to be able to attach my casters to this. So I've got to come up with another plan. Well, it couldn't be easy. That bottom frame section there, that actually is the base that the welder is built on. What they do is that is part of the platform that the main transformers all sit on, the bulk of the weight. And then the cabinet is just bolted to that. So I can't just unbolt these and like have anything to bolt onto, because that literally is part of, it's all welded together. You'll see it better once I tip this over. I'm going to tip it on its side. Hopefully I'm going to get this thing on its side so I can work on it a little bit easier. So for starters, I'm going to take my old wheels off. I got 3 out of the 4 wheels off. One in the back corner is rusted on, so I'll deal with that when I get it over on its side. So now I want to try and tip this thing down on its side, which is going to be tricky. So for starters, I've got the arm fully extended because I needed to do that in order to get it up here in this position. So what I want to do is I want to tighten up this crane a lot more so that when I tilt this, I don't have so much force going out at an angle that way, which could make this whole thing want to tilt up like that and the whole thing fall. So for starters, I'm going to try and lower it back down onto the frame here of the cherry picker, shorten the crane, reattach, and pick it up again. So the last thing I did last night was I lowered it down on some boards and got it tilted, but it's still way too heavy for me to actually push it over. So I had to get some more boards. So today I brought in some more pieces of lumber. I'm going to lift this up again. I'm going to stack this wood even higher under the back so that when I lower it down, it wants to tilt over. And hopefully I can get it to just want to go over on its own and just use the chain fall to slowly lower it down. At some point, it's going to want to try and kick back, probably this way, but I should be okay because it'll just hit the frame of this. So I figure what it's going to want to do now is it's going to want to kick back out this way. So rather than seeing when that's going to happen, I was thinking of maybe just seeing if I can't help it along, get it to slide this way. Oh yeah, not likely. Like I said, I knew what was going to happen. Oh, I didn't want that to happen. Fell off of the leg. No damage, just it's out of position now. Well, while I got it on its side here, let's take a look at the failure that happened. All right, so this is the corner that was tilting down, and we could see what has happened. First, see, I thought it was actually this wheel frame had failed, and it does look like it might be, actually, I don't think that's buckled at all. So the wheels actually held up under the weight. The problem is the steel actually bent. So that's bent in that corner. This back corner's really got some issues because it's rotted and has failed structurally. This right side is actually in a lot better shape. There is a slight bend in over here. But the overall problem is the general construction of this thing. You see these pieces of angle iron that are actually welded in, actually act as supports or struts. So, if these would just come off of the bottom, then I would just make something to replace these. Very similar to what they are. The problem is that there are no bolts going up through the bottom of this to attach this to the body. All of these cross pieces right here, they're all, including these really wide ones, they're all welded to the top of this. And that forms the base of the whole machine that the transformers are actually mounted on. So the big giant transformers, you can kind of see them in there. In fact, the laminated cores of the transformers are right here. And the way this is supposed to work by design, which actually I think is the design flaw with this machine, is that the big huge fan that's on the back is blowing out, which creates negative pressure in the cabinet and causes the unit to pull air in, which is why this has to be up off the ground. Pulls air in underneath here, up through this grate, and cools the transformers first and then any other components, and it gets exhausted out the back. The reason why I think that's kind of a flaw is because, you think about it, this is going to be on dirty shop floors in many situations, so a lot of dust gets pulled into there. 3¼ inches wide. Let me see what I could find out there in my metal pile. Well, I found this in my junk pile. This is nice heavy gauge steel square tube, and what this actually was this used to hang from chains from a post at the entrance to a bank ATM drive-through that had an overhang, and the idea was that if you didn't have this clearance of 8 feet 3 inches and you tried to drive in, you would hit this and it would make a noise and let you know that you were in trouble before you hit the building. I took a measurement. Turns out the inside diameter of this is going to be wide enough that the existing feet on the welder would be able to fit in there. So what I'm going to do is I'm going to cut this in half and make 2 C channels out of it. and then I'm going to bolt it to the sides of the existing legs. Outside diameter of this is wide enough that it'll accommodate the holes, the hole pattern for my new casters. I'm not going to worry about these for right now. I can just cut those off with the cut-off wheel later. You know, so I could handle cutting this in half, lengthwise, any number of ways. I could do it with an oxyacetylene torch, but then I'm going to have to mill it anyways to clean it up and get it, you know, the right diameter. I'm going to probably have a lot of waste and mess. Same thing with the plasma cutter. It'll be a cleaner cut, but I think I'm just going to go right to cutting it right here on the milling machine. I could mount the slitting saw and come into it from the side with a slitting saw, but my slitting saws are high-speed steel. I'm going to have to constantly lubricate them and run it really slow, and my auto feed motor is not working on this. That's another repair I need to do. So I got to do it by hand. So instead of messing with that, what I'm going to do is I'm going to mount it like this, and I'm going to go right down the middle with a small carbide end mill. So I want to try and cut this in half and end up with two halves that are as close as possible to the same height, ideally. But it's not critical. So what I'm going to do is I'm going to use these quick stops that I have, which these are, they have a bevel on them, and these fit right in these T-slots. Now these are for a Bridgeport, and my understanding is that normally they actually are kind of almost a tight fit and they have to be tapped in. On my mill, either due to the wear in the grooves or just because it's a Wells Index as opposed to a Bridgeport, there's a slight difference in the size of the grooves, I guess. So these slide in pretty easily. So they can rock a little bit, so I wouldn't want to use these if I really wanted precision. But again, I'm not looking for really high precision on this job. Now I want to align the center line of the mill spindle right over the center line of this. So I could use an edge finder, locate the edge, but I got a rounded corner here I've got to deal with. I could just put a piece of flat stock up against it and, you know, have my edge finder hit that, but I'm just going to cut right through all of those steps because, again, I don't need the level of precision. I'm going to use my square. I'm going to hold that like that. I'm not holding it like this because I don't want to deal with problems with this edge. Alright, I've already got the blade loosened, so I'll hold that flat. I'm holding this flat to this. Slide the blade over till it touches. I'm going to lock the blade. There's my overall. And well, wouldn't you know, it's just a hair over 4 inches, which is what I would have expected. Now I'm going to reset my square to half of this dimension, which is 2 inches and half of that hair. If I want to get picky. So I'm going to hold the square and I'm going to use a carbide scribe. And I've scribed the line right there. Now I've mounted my Fisher tap follower. Just got a sharp point on it. I've mounted that in the collet, and I'm just going to eyeball, bringing this y-axis over. That looks pretty good. So now I'll lock that axis and go find a carbide end mill. table's not quite long enough for me to make the full length of the cut. So I'm just gonna loosen up my hold downs and slide the piece down this way on the table and cut that last few inches on the end there. Then I'll flip it end over end. Again, just keep my my quick stops in place. Flip it end over end and cut the other side. Alright, so I've cut slots right down the middle, end to end, both sides. And the reason why it's not falling apart is because of these end plugs that are welded in, which actually is pretty great because that really helped reduce the amount of chatter I would probably be getting and vibration as the other piece separated. I would have had to have had a whole lot more hold downs on there, that's for sure. So originally I think I said I was going to use a carbide end mill, and what ended up happening was I snapped one. Actually, I snapped two. Second one I think might have been a used one that probably was already dull, but after I snapped two of them I realized I'm putting too much side pressure on it. I'm probably not having the RPMs up high enough, kind of being a little wimpy about it, so I just figured I'd go with low and slow with the high-speed steel. And I was able to do it with one high-speed steel cutter, both sides, no lube, so I'm happy with that. I'm just going to use a cordless grinder with a cutoff wheel and freehand cut a slot right here. Do the same thing on the other end. That'll put these two pieces into two halves. Then I'll throw them back up here on the table and I'll mill the edges so that it's all even. I don't really need to do that operation, but it'll just make everything look a little neater, so what the heck. So I used the cutoff wheel and was able to actually make a pretty straight cut. This is the top of that sign. So this had the eye bolts in it. Turned out all they had done was drilled holes in the top, stuck a full-length eye bolt through, and then welded around the top. So when I cut off the eye bolts, the eyes on the top, this was left underneath. So I had to use a small cutoff wheel on a die grinder to actually reach down in here and cut these off. Then I wanted to smooth this surface here flat where these welds were, and when I ground these down I could see the ghost image of the rest of the eye bolt, so I just decided to punch them out. Now this one has a weld bead from the manufacturing process of the square tubing on the inside here, and that sticks up a little bit. So I was going to try and grind that off, and then I realized it's going to be easier to probably just mill it off by reaching down in there with an end mill. The reason why I want to take that off is so that that can sit nice and flat against my old leg surface. And I'm also going to use the face mill to clean up my cuts on the end here that I did with the cutoff wheels by hand. So there's one done. Face mill did a really nice job of cleaning out that bead. I don't know why I said it's done. I still have to drill the holes to mount the casters. I think I'm pretty lucky with the size of this thing. It actually only ends up being a few inches long. And rather than cut it down to size, I'm going to leave it long just so I can retain this welded in plate on the end, which gives it a little more structural integrity. I used my transfer punches to mark the holes for the feet. I circle the holes right after I make them with a Sharpie. Makes it a little bit easier for me to find them. These are actually mistakes that I made because at first I put the foot all the way out to the edge here, and then I realized if I did that, I run the chance of the bolt head interfering with this side plate or this side corner, so I moved it over a smidge. Now I've got my edge finder, my Starrett edge finder with the cone point. Got that in my drill chuck. Some people will tell you never put one in a drill chuck, but I'm putting it in my drill chuck. I'm not going to slap a collet in there just to locate the holes. What I'm going to do is I'm going to put that point in that indentation as close as I can get it. Okay, let's get some drill bits. One down, 15 more to go. Alright, so there they are. So I've already removed the last caster of the old casters that was stuck on there. And I repositioned the welder. So now I'm just going to lift it up, slap these things underneath there, lower the weight down on them and see how they act. Well, not working out like I had hoped. I tried sitting the existing legs down inside here like I wanted to. One of the problems that I realized, but I thought maybe it wouldn't be that big of a deal, is the bolt head sticking up. They basically eliminate the nice flat surface inside here that I worked so hard to get by grinding out that bead. The heads stick up. So I could put spacers in here. I could put a spacer strip in here that would, you know, give it full support along the whole length there. But this leg, I think, is so bad that it's still going to be a problem. So then I thought, well, the heck with it. Why don't I just ignore these legs? This is so high now with these new casters. Why don't I just place these inboard of the legs like this? The problem is on that side, for some reason, the metal grate that's underneath here kind of like curves down. I don't know if it's bent or for whatever reason. I can't get that one to go all the way up against the inside of the leg like I wanted to. Even if I move that one out and I lower it on there, it's not stable. So I would end up having to put bolts up through these up into the cabinet somewhere. And the problem is the transformers are there. So I really need to mount these outboard. So I'm thinking now I'm going to do what I was trying to avoid having to do before and cut these legs off so that I can mount these out here in this position. Even if this had worked, the other problem it creates, see how I have this sticking way out? That's because the leg wouldn't swivel. It would hit this. So get a load of this. I was just using a cutoff disc and cutting that leg off using my DCG 414 60 volt max brushless DeWalt cordless grinder, which I up until just now was raving about. And all of a sudden this happened. Yeah, there's basically a fire going on inside here behind the intake screen. Didn't shut down, no warning, nothing to indicate it was overheating or anything. It just blew up. And I could tell just by looking at that smoke that this is a permanent failure. This isn't going to be it'll cool down and be okay tomorrow. So I'm not too happy. This is not that old. Hopefully I'm still under warranty. That was really a pain in the butt cutting these off because I just lifted it straight up to the air so there was no weight on the leg. Used cutoff discs with my angle grinder and cut a slot right along here. The problem is, the reason why this isn't coming off is because of these inboard struts that are holding it on. So now I've laid it on its side so I can cut those struts out, and then those pieces should come off. Now I've got some clearance, I can take the other angle grinder and cut these off. Boy, I'll tell you, finally got this done. This thing was really built to last, like an army tank. So on this top piece here, what I ended up doing was, you know, I had already cut the slot. I had to deal with those struts again, only because I'm dealing from the angle here, it would have been difficult. I would have had to lay on my back practically to try and grind those. So I tried a different tact with those. I just ended up cutting across this piece in sections and then beating it, bending it down, and then bending it back up, bending it back and forth several times, and was able to snap the welds that held these pieces in. So you can see it's just angle iron that they put in there like struts. So this looks like heck right now. I mean, it was pretty tough for me to freehand cut this. I couldn't even get all the way through in one wheel without the wheel wearing down pretty far. So doesn't matter though. What I'm going to do is I'm going to cut some slots here so that my new pieces, instead of going over this, which would leave the outboard part of my new leg sitting out here and could twist, and then I would have to bolt it through to this, and then I'd be relying on the shear strength of the bolts, I mean, which probably would work just fine. But rather than do that, I'm going to have the one side of that foot actually sit inboard on this, and then the other side of the foot's going to sit in here, in this area, which is why down here I had to cut this diamond pattern grill, because they had tack welded it in spots to this, and it was curled up like that, and it was kind of getting in the way. So I just cut these slots right here on these end pieces. So now you can see what I meant. This is going to be able to sit right in here like this. I think that's going to work out fine. Well guys, I finished installing those legs and ended up backing up, cleaning up the joint, and I'm really satisfied with the way it turned out. It's nice and sturdy, it's stable, wheels around a lot easier than it did on those old casters that I had on there. These casters, the toolbox that they were made for must have been pretty big and heavy, because they just seem really well made. They also have a nice click on, click off feature, which is kind of cool. So there's two tabs on the movable casters, one clearly marked off and one clearly marked on. So right now I've got them locked. Hit the off, pops up into that position. That allows the wheels to turn and also to swivel. And when you put it in lock, which it goes in real easily, when you snap them to the lock position, not only does it stop the wheel from turning, it also stops the caster from swiveling. which is kind of neat. So, and the only other thing I did was last night before I went to bed was I drilled a couple of holes right through the sides and zipped in a couple of lag screws. And really those are just there to keep the bottom pieces up into position if for some reason in the future I need to lift this thing up, which hopefully I won't have to do, but I figured why not. Alright, so that's going to bring this project to a wrap. Hope you guys enjoyed this video. If you're not already a subscriber, please consider subscribing, and as always, if you like what you see, please hit the like button. Take care.